Ever wondered how artificial neural networks work? Well, let's dive into it. Artificial neural networks, or ANNs for short, are computing systems that are inspired by the intricate neural networks of the human brain. Now, we all know that our brain is a powerful pattern recognition machine. It absorbs information from our surroundings, identifies patterns, and learns from them to adapt and evolve. In a similar fashion, ANNs are designed to mimic this learning and pattern recognition process. They absorb data, identify patterns within this data, and learn from them. This learning process enables ANNs to perform tasks, make decisions, and even predict outcomes based on the patterns they've recognized. Their design is a testament to the beauty of our own neural networks, reflecting our brain's ability to constantly learn and adapt. Now that we have a basic understanding of what ANNs are, let's delve deeper into how they function. How are these artificial neural networks structured? Diving right in, let's explore the three main components of an artificial neural network, or ANN. These components include the input layer, hidden layers, and the output layer. It all starts with the input layer. This is where the ANN receives data. Think of it as the grand entrance for all the information that the network is going to process. Next, we move on to the hidden layers. This is where the magic happens. The hidden layers are like the engine room of a ship, where the data is processed and transformed. These layers can vary in number based on the complexity of the problem at hand. The more complex the problem, the more hidden layers you might need. Finally, we reach the output layer. This is the destination of our data journey, where the final result is delivered. It's like the grand finale of a firework display, revealing the answer we've been seeking. But what's inside these layers? Each layer is made up of nodes or neurons, which are interconnected. Imagine a bustling city with roads connecting various locations. Each connection or road has a weight associated with it. These weights are like signposts, guiding the data along the most efficient route. So we see that the structure of an ANN is complex yet fascinating. But how does this structure help in learning? How does an artificial neural network learn, you might ask? Well, the key concept here is training. In essence, an artificial neural network, or ANN, learns much like we do, through experience and correction of errors. When an ANN is being trained, it is presented with a set of input data. The network makes predictions based on this data, using its current understanding of the connections or weights between its artificial neurons. But as you can imagine, these initial predictions aren't always spot on. That's where a wonderful thing called backpropagation comes into play. Backpropagation is like the network's personal tutor, guiding it through its learning journey. When the ANN's output doesn't match the desired result, backpropagation steps in. It calculates the difference, or error, between the predicted and actual output. Then, the magic happens. Backpropagation, working its way backward through the layers of the network, adjusts the weights of the connections based on this error. The goal? To minimize the error in future predictions. This process is repeated, often many thousands of times, with the network gradually improving its performance with each iteration. It's a bit like practicing a musical instrument or a sport. The more you practice, the better you get. And just like that, through a process of trial, error, and constant adjustment, the ANN learns from its experiences and hones its ability to make accurate predictions. That's how ANNs learn and improve their performance, but what are the applications of these networks? Where are artificial neural networks applied, you may ask? Well, the reach of these networks is vast and ever-expanding. Let's take a look at a few examples. In image recognition, ANNs are used to identify and classify objects within a picture, a task that benefits immensely from the pattern recognition capabilities of these networks. They're also extensively used in speech recognition, transcribing spoken words into written text, and even understanding the context of the conversation, and it doesn't stop there. ANNs are also instrumental in predicting stock market trends. By analyzing past data and recognizing patterns, these networks can make informed predictions about future market movements. Artificial neural networks, much like our own brains, are exceptional at identifying patterns and making connections. They are the backbone of many modern technologies, and are continually pushing the boundaries of what machines can learn and do. Artificial neural networks, inspired by our brain, have truly revolutionized the way machines learn and recognize patterns. Let's recap what we've learned today. We've delved into the fascinating world of artificial neural networks, unlocking their structure, composed of interconnected nodes, or neurons. We've explored their learning process, a dynamic journey of adjusting weights and biases. We've also seen their remarkable applications, from image recognition to natural language processing, truly demonstrating the transformative power of these networks. And there you have it, a step-by-step exploration of artificial neural networks. Stay curious, keep learning,